In today's session, we are going to see one more product of the dyes intermediate, and that is coach acid. So this coach acid is very much similar to the H acid, and its process description and even its flow sheet is very much similar to the H acid. So let's just quickly understand what are the different properties of this coach acid. As you can see here, its chemical name is the coach acid or 1-naphthalamine 368 trisulfonic acid. So as you can make out from its name, it has 1-naphthalamine, right? So if you look at the structure of this particular chemical, then we have here one SO3H like this. Instead of this, in a H acid, we were having OH group, right? Hydroxyl. Now coming back to the property of H acid, its molecular formula is C12H9N1O9 and S3. It has molecular weight of 383.3 grams per mole. It is very much soluble in diluted alkali solutions, and its appearance is light brown crystalline powder. So this was the all properties of coach acid which can be asked in a 1 marks MCQ questions or even different competitive exams. Now after saying that, let's just focus on the different raw material that we are going to require in order to produce coach acid. These raw material are very much similar that we have used in the production of H acid as well. So we are going to require sulfuric acid and 62% of olein in order to get sulfonation reaction, in order to impart our SO3 group on the naphthalene base. Then we are going to require nitric acid, RNs. Then we are going to require nitric acid, acetic acid and HCl. Now after this thing, let's just quickly understand what is the chemical reaction that take place in order to get our final product of coach acid. As you can see here, this reaction starts from the naphthalene. We have to undergo this naphthalene inside the sulfonation reaction, in which we add sulfuric acid and 62% concentrated oleum at the temperature of 150 degrees Celsius to 180 degrees Celsius. Again, this reaction is very exothermic reaction, so we have to circulate our cooling water outside the jet. Then it will ultimately produce naphthalene, which has the 3 sulfonating group in the 3rd, 6th and 8th position. So as you can see here, this chemical substance is known as naphthalene 368 trisulfonic acid, which has 3 sulfonic acid group as SO3H. Now we have to go through this nitration reaction, in which we add mixed acid of nitric acid and concentrated sulfuric acid. On the application of mixed acid, we will ultimately have this NO2 group on the 1 position of this naphthalene, which will ultimately have 1 nitronaphthalene 368 trisulfonic acid. This chemical reaction is very much similar to the H acid chemical reactions. So if you have remember H acid reaction, then it will be very easy to understand this chemical reaction. Now this particular substance is undergone the reduction reaction, in which we replace this NO2 group with the NH3. So now this is the reduction step, in which we are replacing oxygen group with the help of hydrogen group, right? In which we have to add our iron and all this stuff. So after this reduction step, we are going to get our coach acid as the final product. So this was all about the chemical reaction that is being taking place for the production of the coach acid. Now after understanding this chemical reaction, let's just focus on the flow sheet of the production method of H acid, of coach acid. As I have already told you that this is the very much similar kind of the structure that we have seen in the H acid. So as you can see here, we are going to require same type of the different vessel made up of the cast iron and the stainless steel. In this particular sulfonating reaction, we are adding our naphthalene and we are also adding sulfuric acid and 62% concentrated oleum. This reaction has to be followed in the cast iron vessel in order to reduce the corrosion effect by the sulfuric acid and wood. We have to also use one agitator so that we can have complete picture of our final product of naphthalene 368 trisulfonic acid. Now this reaction mass is then sent to the nitration unit, which operate at minimum temperature of 40 degrees Celsius. In order to achieve this temperature, we have to ensure that we have to circulate this cold water or the chilling water throughout this jet. So at the end of this nitration, we will have 1 amino naphthalene 368 trisulfuric acid, which is being then sent to the neutralization tank, where we neutralize our reaction mixture with the help of soda lime, soda ash and lime water. So again we have to ensure that temperature do not exceed the 80 degrees Celsius, and we have to maintain this temperature for several times so that we can easily get the precipitate of our reaction. And this precipitate can be separated out by the filtration, in which we remove our sludge and then we send it to the landfill. Now our then filtrate is being sent to the reduction unit, where we achieve a reduction of nitro group, that is your NO2 group, with the amine group of NH group, right? So we have to replace our oxygen with the hydrogen, and that is being achieved in this reaction, in this reduction unit, in which we have to add our catalyst of iron and acetic acid, and we have to add soda ash so that we can ensure there is complete mixture, and we have to precipitate our reduction mass. Then this reduction mass is being sent to the filtration unit, where we recover all the precipitate and we remove the sludge. This iron sludge is again sent to the landfill unit or to the ceramic industry, where we utilize it as in the form of the gypsum. Then this filtrate is being sent to the isolation unit, where we are actually isolating our coach acid that is being generated from the previous step. Then this isolated coach acid is being filtrated, and then it is being sent to the centrifuge in order to separate all the liquid with the help of the centrifugal force, and we have to separate solid and liquid of the coach acid. Then slurry coming out of this centrifuge is sent to the dryer unit, where we remove all the moisture and we have to remove all the water, and it is being sent to the and ultimately we get the fine powder of the coach acid. So this was all about the flow sheet, right? I am not repeating this flow sheet as it is very much similar to the H acid that we have seen in the previous video. Now let's just quickly understand what is the process description for the production of this coach acid. As you can see here, the first step is very much similar to that of we have seen in the H acid. So the first step is the sulfonation, in which we are reacting 62% of olein and sulfuric acid that is being taken inside the cast iron jacketed vessel of the sulfonating, right, which is also having one anchor type of the agitator. Then we have to cool our reaction mass of the acid at 20 degrees Celsius by circulating chilling water inside the jet. And then we have to add our naphthalene slowly, so that for the period of 2 hours and 2.5 hours. And we have to add this naphthalene in such a way so that temperature do not exceed to the 35 degrees Celsius. This all the exercise that we have understand in the previous video of the H acid, right? Then after addition of this naphthalene, we have to heat our reaction mass for the 85 degrees Celsius with continuous stirring by using steam, right? So this was all about the sulfonation reaction. Now after sulfonation, the next steps come in a picture is the nitration, in which this sulfonated mass is being sent or transferred inside the cast iron jacketed vessel, or we can say sulfonating or the nitrating reactor, which also has anchor type of the agent. The nitrating mixed acid, that is your concentrated sulfuric acid and nitric acid, is being added inside the reactor, in which we are also passing cooling water throughout this jacket. This addition of nitric acid or mixed acid has to be in such a way that the temperature do not exceed 40 degrees Celsius. And the addition period for this nitric acid is around 12 to 13 hours. Then we have to maintain the temperature of 40 degrees Celsius for 3 to 4 hours, and we have to produce the 1-nitronaphthalene 3,6,3,4,6 trisulfonic acid. And after this nitration step, next step is the neutralization and the filtration, which is again similar to the H acid. The reaction mass having pH of 1.3 to 1.5, it is being neutralized with the help of the soda ash or the lime water. This mixture is then continuously be stirred for this 3 hours, and we have to maintain temperature of 80 degrees Celsius. This batch is then continuous stir for the 1 to 2 hours, and we have to adjust pH for 6.5 to 7.5 pH. And to achieve this pH, we can also use more amount of the soda ash and the lime solution and the lime water solution. And thereafter, sludge is being removed by the filtration units, and then filtration mass is then further processed. Now, after this filtration unit, the reduction step comes in a picture, in which we add gaseous acetic acid and iron first. So this iron acts as the catalyst, and inside which we are adding our filter smart in order to get the reduction of our nitro group, that is your NO2 group, into the amine group of NH3. And This reaction filtration mass is continue to stir, and we have to maintain temperature of 90 to 100 degrees Celsius for the 3 to 4 hour of the complete reduction. So after the completion of reaction, we have to maintain the 90 to 100 degrees Celsius temperature for 3 to 4 hours. Then after that, we have to filter our reaction mass, and we have to remove the sludge, or we can say iron sludge. Then this reaction mass is being sent to the next step of the precipitation and the filtration, in which we have to create precipitate. Here, the pH of the filtration mass is around 8 to 10 pH. So by mean of 30% hydrochloric acid, we are controlling this pH, or we are reducing pH up to 3 to 3 pH in order to get the precipitate form of our coach acid. And later, this precipitate of coach acid can be easily filtered out, and we can easily separate our solid and liquid form of the coach acid by mean of the centrifuge. And after that, this slurry is being sent to the drying unit, where we remove all the moisture and we recover coach acid. So it is being observed that 512 kg of the dry coach acids can be obtained from 875 kg of the naphthalene, and the percentage yield is around 55 to 60%. So this concludes the production method of the coach acid.